Last class, we talked about factoring out a greatest common factor from a polynomial, okay? We've also, though, been spending a lot of time multiplying polynomials. So, for example, I may have asked you to multiply something like this, x plus 1 times x plus 3, okay? And no matter how you do it, whether you use distribution or whether you use the box method, when you multiply this out, you're going to get x times x is x squared. And then I'm going to do both of these steps at once. X times 3 is 3x, plus 1 times x is 3x plus 1x is 4x altogether. And then 1 times 3 is 3. Okay, so I did the middle step like just in my head. Okay. Now, this does not have a common factor. There's no common factor amongst these three terms, okay? But it is factorable. It's factorable. We know it's factorable because we started by multiplying two binomials together to get this product. So although this doesn't have a greatest common factor, it can be factored into the product of two binomials. So our goal today and into next week is to figure out, how does that work? How do we do that? Yes?
Is factoring on the quiz we're doing?
No. Okay. So we're going to do some exploration to start with some algebra tiles. And actually, before I even go there, what I want to remind you of is the area model of multiplication. And using area, we can actually figure out the factors of any number. So for example, if I give you the number 12 and I want to know the factors, imagine you have 12 little tiny squares and you're trying to make them into a rectangle. You think, how many ways could I do that? Well, I could make a really skinny long one. That's 1 by 12. Okay, what's another way I could do it? Yep. 3 and 4, yeah, and what's the third way? Yeah, 2 and 6, so I could do 2 by 6. Or I could do 3 by 4. And those are the only ways that I could do it. So these are the only factors of 12. 1 and 12, 2 and 6, 3 and 4. Okay, the important piece here is that if a polynomial is factorable, we must be able to make it into a rectangle of some sort. Because when we make a rectangle, we multiply two things together, we end up with a rectangle. Okay? So what we're going to do is we're going to take a look at this guy. And, oh, whoops, I have to find the things that I want. I'm going to take out these tiles. So we've got one x squared tile rather. Come on, there we go. There's an x squared tile. We've got 4 x tiles. 1, 2, 3, 4. And we've got 3 ones. 1, 2, 3. And we want to imagine that these are like puzzle pieces. So we've got these puzzle pieces. The shape of the puzzle must be a rectangle. So I could like try and say, okay, well, I'm going to fit these ones together. So that so far is a rectangle. Then I've got to fit in these 3 ones. So if I try and do it down here, that's not going to work because it doesn't make a rectangle. I've got this like empty space over here. I could try doing this. That's not going to work. I could put them up here. That's not going to work. Okay, so what I have right now isn't going to work. Oh, I need another one. Oh, no, I've got 4. Okay, good. Okay, so it seems like because the x squared tile and the x tile have the same side length, they have to join. But is this the only way that I could put the x tiles into the puzzle? No, okay, so give me an idea. What could I do? Yeah. Yeah, I could do this. I can move as many of them as I want to go this way and then try and fit these in. And that makes a rectangle. Now, what are the factors going to be? The factors are the side lengths, right? When I had an area of 12, the factors were the side lengths of that rectangle. So this side length over here, oh, whoops, I didn't want to do that. There we go. Okay, this side length, well, this is x plus 1, 2, 3. This is x plus 3. And this side length over here is x plus 1. And those were the two factors that we started with. When we multiplied them out, we ended up with x squared plus 4x plus 3. Okay, so we're going to start with that one. I'm going to give you, we're going to do two more. Then we're going to try and see if we can notice anything. So let's try this one. Let's say I have x squared minus 7x plus 10. Okay, so what am I going to start with? I'm going to start by taking out these tiles. So I need one x squared tile. I need 7x tiles. There we go. One. No, sorry, you're right. I need 7 negative x tiles. Thank you. Okay. I need these guys. 1, 2, 3, 4, 5, 6, 7. Okay, and then I need 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I got my puzzle pieces, and I need to try and put these together. Okay, so again, I'm just going to put the x squared tile here. I could put it anywhere, but I could try and do this. Right, so I could try and line these up again like that. But then when I try and fit these in, they're not going to fit anywhere, right? There's not going to be, the 10s over here aren't going to make the rectangle. So what could I do instead? What could I do instead? Do these negative 7x's have to go all down below? No. Okay, so what's another spot I could put them? Where else could I put them? Yeah, I could put, let's try, I'll take the bottom one actually, then I don't have to move them all. Okay, let's try moving this one here. Now if I try and fit the ones in, 2, 3, 4, 5, 6. Okay, so that's not going to work because I still have 4 ones to fit in. So what do you think I could do next? Still have these 4 leftover ones. Yeah. Yeah. Let's try this. Okay, so now I could put 1 here. Yeah, and now there's space for these extra 4 ones, and they fit into a rectangle perfectly. Okay, and now if I look at the side lengths, well, over here, what's that side length? Yeah. X minus 5, yeah, because this has a side length of x. These each have a side length of negative 1. So this is x minus 5. And then what about up here? Yeah. X minus 2. And in fact, this is true. This is equal to x minus 5 times x minus 2. Okay, so you guys can try that if you want, but essentially x squared minus 2x minus 5x, that gives me the negative 7x, and then negative 5 times negative 2 is plus 10. Okay, so that's how I would factor that one. I want to look at one more, and then we're going to see if we can make some generalizations here. Okay, so let's say I have x squared plus x minus 2. Okay, so I'll take those tiles out. There's my x squared tile. I need an x tile, and I need 2 negative 1s. Okay. So let's see if I'm going to be able to do this. What do you guys think? Can I make this into a rectangle? Here are my tiles. What can I do here? Is that going to in any way make a rectangle? No. Okay. Because I don't have, like, I almost need more X tiles to fit in here, right? So that I could put these here somewhere or something like that. Okay. Now, we can do a little trick, though. We can add in more X tiles through zero pairs. Do you guys remember what a zero pair is? Yeah, so if I take like a positive 1 and a negative 1, that makes 0. If I take a positive x and a negative x, that makes 0. If I take a positive x squared, negative x squared, that again makes 0. So let's try doing that and see what happens. If I take a positive x and a negative x at the same time, this is still 0. This is still the same polynomial that I started with, right? Because these guys equal 0. But now I can do this. Whoops. And now I have a rectangle. Okay, so that's another thing that could happen, is that you may actually have to add in extra tiles through zero pairs to be able to make your rectangle. This one, whoops, has a side length. What's the side length along there? Yeah, so here's x plus 1 plus 2. And here? Yeah.
Would be x minus 1.
Yes. Okay, and again, if you multiply those two things together, you get this. Okay, so we want to try and figure out what's going on here, because ultimately, this is a really good way of understanding how to factor, right? Okay, we make a rectangle, but it's not super efficient. So we're going to see if we can notice some sort of a trend so that we can generalize a little bit. Okay, so what I'm going to point out to you guys is this. Every time I make a rectangle, the rectangle is kind of divided into two parts. Okay, I've got, or four parts rather. Okay, there's the x squared tile in the top left corner, some x's in the top right, some x's in the bottom left, and then the ones go in the bottom right. And that happens every single time, right? So here again, x squared tiles, x, x, and ones. And same thing here, right? So the x squared tiles kind of stay together. I mean, we only had one of them in this case, but they will stay together. The ones stay together, but it looks like the x tiles, or the x term, gets split up. That's going to be a very important step to factoring. Okay? So that's one thing that I want to point out. The other thing that I want to point out is, like, how do we figure out how it gets split up? Well, here we have 3 and 1. Okay? Here we have -5 and -2. And here we have 2 and -1. 2 of them and -1 of them. Okay? Now, we want to relate this back to the polynomial that we have to factor, because that's really the only thing that makes one of these different from another one, is the coefficients of each term. Otherwise, they're all the same. Okay? So let's see. The coefficient of x squared is always 1 in the examples that I've given you so far. Okay? So we're not going to focus too much on that. But let's look at this. Here we have 4. Here we have 3. These got broken up into 3 and 1. Okay? Here we have -7 and +10. And these got broken up into -5 and -2. And then finally here we have, this is +1 and -2. And these got broken up into 2 and -1. So what we want to try and do now is make a connection, right? What's the connection between the way they get split up and those two, either the coefficient or the constant, those two numbers, in the polynomial. What can you see? So the numbers here were 4 and 3, and these got broken up into 3 and 1. How can we get the numbers 4 and 3 through the numbers 3 and 1? And then similarly here, we had the number -7 and +10, and they got broken up into -5 and -2. How do we get the numbers -7 and +10 through those two numbers? Yeah?
Well, you can provide like the like terms, but then also for like the constants you can multiply them.
Yeah, so it seems like these two numbers add to -7 and multiply to 10. Okay, these two numbers in the second one, in the first one I gave you, 3 and 1, 3x and 1x add to 4x and multiply to 3. And then that works out too with this one where we had to add in a 0 pair, right? So this number is 1. We have 2 and -1, that makes 1. And this number is -2. Well, 2 times -1 makes -2. Okay, so it seems like something's going on here. All right, now I'm going to turn to your notes, to lesson 4, I believe. We're going to just barely start this today, and then we will continue it much more on Monday. But we're going to try and figure out if we can come up with a process to do this so that we don't have to keep taking out algebra tiles and making rectangles, essentially. Okay, so here we are. This is page 10. Okay, and what we're going to try and do today, and again over the course of the next couple days, is figure out how do we factor trinomials that take this form, ax squared plus bx plus c, where here a, b, and c, well, I'll do this in black and thinner, a, b, and c are numbers. Okay, that's really the only thing that makes one of these different from another one, is the values of a, b, and c. Okay, now let's just write some examples of polynomials that could take that form. Well, we already saw a couple of them, right? So we did, what did we do? We did x squared plus 4x plus 3. We did x squared minus 7x plus 10. We did x squared plus x minus 2. There's 3 examples. You could also, oftentimes, the coefficient of x squared, which is the a value. That's a is the coefficient of x squared. Doesn't have to be 1. So we could have like 5x squared minus 2x plus 12. You could have something like that. Okay. You could also have something like this. 2x to the 6 minus x cubed plus 4. Okay, now why is this of that format? Yep.
Because the coefficient to x or x cubed is 1.
Not exactly. This, again, right, it's supposed to be x squared and x. This is x to the 6 and x cubed. Well, why is it of that form? Because we can actually write it that way. We can write this way. Right? So this, if we take this to be like the quote-unquote x, we can square it. And this one would have an exponent of 1. Okay? So in general, the coefficient of the first, or the exponent rather, on the first term just has to be double the exponent on the middle term. Okay? You could also have something in 2 variables. So for example, this one, the first one in 2 variables, we're going to deal with this next week though. X squared plus 4xy plus 3y squared. That's also of that form. Okay, but we'll talk about that more later. Okay, now why is it important to learn about these and how to manipulate them? Because these expressions, when put into a relation, right, y equals x squared plus 4x plus 3, for example, model lots and lots and lots of different things in the world. And you're going to learn more about that next year, okay? And the shape that it makes, I think I threw a pen or something last week. I don't know if it was this class or the last one. It makes a parabola, which is like projectile motion. So it makes this sort of arch, okay? So we're going to learn how to deal with these this year algebraically, and then go further with them next year. Okay, now how do we factor these? Well, there's 3 different strategies that we can use, okay? One of them is called the area model, and this basically undoes the box method of multiplying, okay? The second one is decomposition, which basically undoes distribution. And then there's also guess and check, which doesn't really undo anything. But it's really fast if you're good at doing stuff in your head, okay? Now, the first step for both area model and decomposition is the same, okay? Now, remember, when we looked at the algebra tiles for these 3 guys, we had to split the x tiles up into 3 and 1. That multiplied to 3, added to 4, right? So 4 is the b value, 3 is the c value. Now what I'm actually going to do here is I'm going to write in the coefficient of x as well, because that is going to come into play. The second one, we had to split it up into -5 and -2. That multiplies to 10, adds to -7, right? And this continued. Now in general, we have to find those special 2 numbers as to how to split up that x term. And the way that we need to do it is we need to find 2 numbers. So this is step 1. That meet the following conditions. They have to multiply. Seems like they have to multiply to the constant, right? These had to multiply to 3. 3 and 1, 3 times 1 is 3. Here, -5 times -2 is 10. This one was 2 and -1, that's -2, right? So it seems like they have to multiply to the constant, but in fact they have to multiply to a times c. The reason why it didn't matter in the ones that we did is because the value of a was 1. A is the coefficient of x squared. So they need to multiply to a times c, and then they had to add to the coefficient of x. That was the b value. We need to multiply to a times c and add to b. Now, in this example here that we're going to factor, we've got 2x squared plus 9x plus 10. So what's the a value, what's the b value, and what's the c value for 2x squared plus 9x plus 10? Yeah?
A is 2.
Yeah?
B is 9 and 10 is c.
Right. There we go. Okay. So in this case, we need to find 2 numbers that multiply to a times c. That's 2 times 10. And they have to add to b, which in this case is 9. Okay, so can you guys think of 2 numbers that meet those conditions? They multiply to 20, add to 9. Think about what multiplies to 20. Yeah? 4 and 5. 4 times 5 is 20. 4 plus 5 is 9. Okay? Now, if you can do that in your head, that's fantastic. But if you can't, I want to show you a systematic method of finding those 2 numbers. And it always starts with the first condition, because there's only a finite set of numbers that multiply to 20, whereas there's infinite sets of numbers that add to 9. So start with this one. Okay? Now, what multiplies to 20? Well, we could start with 1 and 20, right? We could do 2. 2 works. 2 times 10. 3 doesn't work. 4 does work. 4 times 5. And then the next number we check is 5, but that's already on the list, so we're done. Okay? Now, one thing I should mention is that every pair has sort of a partner pair where you swap the signs. So also, -1 times -20 multiplies to 20. -2 times -10. And -4 times -5. Okay? Once you have an exhaustive list, then you should be able to find the pair that add to the b value, right? So here the numbers are 4 and 5. Okay? Now the second thing we're going to do is we're going to draw a box. And we're going to draw a 2 by 2 box because when we actually looked at the algebra tiles, remember it was divided into 4 sections? Okay, the x squared term went at the top left. So that's where I'm going to put the x squared term, which was 2x squared. The 1s always went on the bottom right. So that's, in this case, 10. And then the x terms were split up. The way we're going to split up the x term is using these two numbers. So instead of 9x, we're going to have 4x and 5x. Doesn't matter where you put each one. So I could put 4x here and 5x here, or you could swap them. Okay? So that's the second step. Now the third step I'm going to do within the box, but it's basically figuring out some greatest common factors. Now where do we want the greatest common factor? We need the greatest common factor of the top row. What is the greatest common factor of the top row? Yeah. Not just 2, 2x, yes. Okay, so this is the GCF. Now if we factored out a 2x from 2x plus 4x, well, what would we have to multiply 2x by to get 2x squared? Yeah. Yeah, so I'm going to put an x there. Then x times 2x gives me the 2x squared. What would I have to multiply 2x by to get 4x? Yeah, 2. Okay, so that's the first thing. Now, you also want the GCF of the left column up here. But if you've done the first step correctly, this x should be the GCF. And in fact, it is. If you look at 2x squared plus 5x, that has a greatest common factor of x. So I'm going to do things the same thing. So x times what gives me 2x squared? Well, it should be this 2x. And then x times what gives me the 5x? Yeah, 5. These are the factors of that polynomial. Now, how do we write it out? You have to write it in factored form because this is just sort of a graphic organizer. So the fourth thing you want to do is write out the factors. One of them is x plus 2. The other one is 2x plus 5. Okay? All right, so that's the area model or the box model, box method. Okay? The second method that we're going to look at is decomposition. And this is actually quite similar to the area model, but we don't use the graphic organizer to do it. So the first step is exactly the same. Right, so we want two numbers that multiply to 20 and add to 9, and those are, okay, so you guys are going to get a lot of practice doing that. Second step, we're not going to use a box. This is the decomposition step. We're going to decompose the x term. Okay, so the x, it started like this, 2x squared rather, plus 9x plus 10. I'm going to split this up. And again, I'm going to use these two numbers to do so. So plus 4x plus 5x plus 10. Okay, so that's the decomposition step. The last thing that I'm going, or this is sort of the second to last thing, is I want to factor the greatest common factor out of pairs. So I'm going to look at this pair and take out a GCF. And I'm going to look at this pair of terms and take out a GCF. Okay, so that's sort of our third step is GCF of first two and last two terms. Okay, so between 2x squared and 4x, what is the GCF? We already did this in the box, actually. Yep.
2x and the other one is
2x, hold on, I'm not there yet. So GCF here is 2x. What's left? Well, 2x squared divided by 2x is x. 4x divided by 2x is 2. And I'm going to do the same thing here. What is the greatest common factor of 5x plus 10? Yep, 5, right. Can't include an x here because the second term, the 10, doesn't have a factor of x in it. So I'm just going to factor out a 5. Now, 5x divided by 5 is x. 10 divided by x is 2. Okay, now what you should have is a common binomial factor. Okay, so essentially, this is 2x times x plus 2. This is 5 times x plus 2. Both of them have a factor of x plus 2 in them. So that's the common binomial factor. I can factor that out. So I'm going to bring the x plus 2 in front. And what's left from the first piece is 2x. What's left from the second piece is 5. And now it's factored. Okay. Now, guess and check is the method that I learned. We didn't ever do decomposition or box method when I was a teenager. The assumption was everyone should just be able to do this in their head. And so I didn't actually learn these other methods until I started teaching. And probably not even in my, I'm ashamed to say this, probably not even in my first year or so of teaching, okay? But luckily now I know them, okay? Now guess and check. If you can do this method easily, this is super fast. If you can't, then what I say to you, what I would recommend is do whatever you think is most efficient, okay? I mostly use this personally, but occasionally I'll find one where I'm like, oh, it's gonna take me a long time to use guess and check, so I better use one of the other ones. Okay, I've got about 5 minutes. Okay, so guess and check. So how does this work? Well, this is how it works. When we expand, okay, if I were to expand this, for example, the 2x squared comes from the x times the 2x. The 10 comes from the 2 and the 5. So really what we're going to be guessing about is this middle term. Okay, so this is what it relies on. We're going to set up 2 sets of brackets. I know that the first 2 terms need to multiply to 2x squared. The only way to do that is with the 2x and an x. The last 2 terms need to multiply to positive 10. So one thing that tells me is that they have to have the same sign. They either both have to be positive or they both have to be negative. In this case, what do they have? Are they going to be positive or negative? Positive, yes. How do you know? Yeah. Well, yeah, but what if I had negative 1 times negative 10? Then I'd have 2 negatives. There's another way that we can tell, though. It's the fact that we have positive x's. Okay, because the x term is positive, these both have to be positive. If the x term was negative, then, because remember, it's like they have to add to 9 and multiply to 20. Well, you either have negative 4 and negative 5, or positive 4 and positive 5. Because I have positive 9, it's got to be the positives. So I know that these are both going to be plus. Okay? Now the question is, what goes in here? Well, now I can make my list. What multiplies to 10? It's 1 times 10, or 2 times 5. And essentially what I'm going to do now is just plug things in and see what works. So let's say I plug in, I'm going to do this in a different color actually, a 1 and a 10. Okay, well, the way that I've set this up, I already know that the first two are going to multiply to 2x squared, and the last two are going to multiply to 10. So I don't need to worry about that. What I need to worry about is the 2x times 10 and the 1 times x. And I want to see, do those add to 9x? So if I go 2x times 10, that's 20x, plus 1 times x is 21x. That's not 9x. So I've guessed this, I've checked it, it's wrong. I'm going to erase it. Okay, now you could also, if you're not sure, switch them. So make this the 10 and make this the 1. Right? Well, now 2x times 1 is 2x plus 10x, 10 times x is 10x. 2x plus 10x is 12x. That's wrong too. So I'm going to erase that. And I can actually cross this off. That's not going to work. So it has to be this, right? And then we know, I'm going to just, to speed things up, put in the correct one because we already know what it is. I might test that one first. And then I'm doing 2x times 2 is 4x plus 5 times x is 5x. 4x plus 5x is 9x, and that's what I want. So that's correct. That's guess and check. Okay? Now, the reason why this can be faster is that if you practice it quite a bit, you'll basically figure out some trends where you'll know where to start in terms of what's going to be the most likely to be correct. Okay? So, and we'll talk about that too. All right, I'm going to stop now and we'll start the quiz. We'll pick this up on Monday.